back, I had a tech walk into my office and ask me if I had a pressure enthalpy chart for R410A refrigerator. After I fell out of my chair and picked myself back up, I got him a chart. I was shocked that a tech knew what a pressure enthalpy chart was. So we're pretty familiar with what pressure is, but enthalpy might cause a little bit of a problem. But basically, enthalpy is the total heat content in a system. So this chart that we're talking about deals with the pressures and the temperatures in a refrigeration system. So this is a pressure enthalpy diagram for R410A. Lots of lines on this thing, which looks very confusing at the first glance. But let's take a closer look at what a pressure enthalpy diagram can do for us. So a pressure enthalpy chart deals with the properties of liquids and a vapor or a gas. So any substance that exists in this world that is a liquid or a gas has a pressure enthalpy chart for it. So all of our refrigerants have pressure enthalpy charts that are associated with the properties of the refrigerant as it exists as a liquid and also as a vapor. So on the pressure enthalpy chart, the lines have to do with a saturated liquid line, and if we move to the left of that line, we get into subcooled liquid. We also have the saturated vapor line, and if we move to the right of that line, we get into superheated vapor. So in plotting the refrigerant cycle on a pH chart, we start with the compressor, the compression cycle. Then we move into the condenser coil, then to the expansion valve, then through the evaporator coil and back to the compressor. We can also plot our subcooling and our superheat on a pH chart. While doing service work on inverter type air conditioners and heat pumps, you probably have seen various fault codes that signify that the system is operating outside its normal operating range. Operating outside of its normal operating range and also high torque or flank loading events signify that the compressor is operating outside of its normal operation envelope. That envelope is seen on the pressure enthalpy chart. So let's look at a few practical examples of how we might use the pressure enthalpy chart in everyday service work. Taking the compression ratio of a compressor, we usually have to convert our gauge pressure to atmospheric pressure. But since the pressure on a pH chart is already in atmospheric, we don't have to do that. By plotting our pressures in this example, we find that our compression ratio is 8.79. So our discharge pressure is slightly less than 9 times that of the suction pressure. The compressor must compress the refrigerant gas almost 9 times to function efficiently under these conditions. Most reciprocating compressors can handle compression ratios up to 15. So at 8.79, we are well within that range. When the ratio exceeds 10, usually a 2-stage compressor is needed. Rotary compressors can handle compression ratios up to 5. Another thing that we can plot on the pressure enthalpy chart is how much latent heat we are either removing or adding to the refrigerant. In this particular example, we're showing latent heat on the evaporator coil, and we are absorbing 91 BTUs per pound of refrigerant. So we have looked at a couple of examples of practical use of a pressure enthalpy chart, and we could go on with many more examples, such as the refrigerating effect that we could plot to see what our coils are actually doing in the system. We could plot the refrigerant volume, how much refrigerant we're moving and how much we need to move in order to achieve the full tonnage of the system. We can plot the heat of compression, which tells us how much heat we're picking up as we go through the compressor. We can plot our condenser and evaporator coils and tell how much sensible and latent heat we're expelling or absorbing in those coils. We can also look at the effect of lowering the condenser temperature, which sometimes we do in order to increase the efficiency of our condenser in hot weather. We can plot our subcooling, we can plot our superheat, and we can also find out what our system capacity is per ton. So there's a lot of practical data that can be achieved from looking at a pressure enthalpy chart.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.